ChatGerry, a combined VMT and TDA analysis of normalized, simple glucose energy versus 3 behavioral stressors over past 9 years, number 1403, VMT sharp 734, TDA sharp 017, October 24, 2025, Gerald C. EclaireMD Foundation. Category, Diabetes, and Simple Glucose Energy. Preface from 2017 to 2025, I analyzed my daily glucose patterns, using a simple glucose energy, N.SGE, model that divides my glucose readings into 3 groups: low, less than 70 mg per deciliter; normal, 70 to 150 mg per deciliter; high, greater than 150 mg per deciliter. I use the normal range, N.SGE %, as a measure of my metabolic output, strain, and compared it with 3 lifestyle input stressors: body weight, BW, carbohydrate and sugar intake, C&S, and daily walking steps. All 3 input variables were normalized, using BW, 170, C&S, 15, and 8,000 steps for cross-year consistency. This study integrates 2 complementary models: the physics-based Viscoplastic Medicine Theory, VMT, and the mathematics-based Topological Data Analysis, TDA. VMT measures energy transfer between stress and strain, while TDA reveals how health variables change geometrically through time. Together, they describe both energetic balance and geometric stability. In diabetes control, VMT analysis. In the VMT framework, normal glucose energy, N.SGE %, is the strain, while BW, C&S, and steps act as 3 input stressors. VMT energy contribution ratios were: BW is 41%, strongest; C&S is 38%, second; steps is 21%, weakest but function as a stabilizer. This means weight and diet dominate total input stress for the strain of N.SGE %, while walking helps dissipate it. The cumulative VMT energy curve rose sharply from 2018 to 2021, then flattened from 2022 to 2025, indicating metabolic equilibrium. In short, my type 2 diabetes condition stabilized around 2021 after years of controlled weight, balanced carbs, sugar intake, and steady walking exercise. Transition to TDA. VMT quantifies internal energy balance but not its geometric behavior. TDA fills this gap by mapping how my metabolic system evolves, in both space domain and time domain. Each year's data, N.SGE %, BW, C&S, steps, forms a point in 4-dimensional space. Principal component analysis, PCA, simplifies these data into 3 axes: PC1, PC2, and PC3, representing independent directions of variation. PC1, main metabolic direction, rising with N.SGE % and steps, decreasing with BW and C&S. Note that 3 correlations between N.SGE % and N1, N2, N3 are -0.76, -0.60, plus 0.62. PC2, secondary balance between diet and activity. PC3, subtle short-term adjustments. From 2017 through 2025, the geometric shape of my data contracted steadily, reflecting improved coherence and reduced fluctuation. The 2022 data point appeared as an outlier, caused by a temporary distortion in behavior. Geometric contraction. The 3D distances from the origin quantify total system stability. Between 2017 and 2021, the geometric distance shrank from 1.75 to 0.66, a 62% contraction. And by 2025 reached a 76% total reduction. This geometric shrinkage means the system became compact, resilient, and self-stabilizing. Radar chart comparison among 2017, 2020, and 2025 also confirmed this trend. The 2025 polygon was larger and smoother, showing stronger balance among the 3 stressors and higher glucose energy stability. Combined interpretation. The VMT model captures the physics of internal energy transformation, while the TDA model displays the geometry of systemic evolution. Both reveal the same pattern: energy dissipation through walking and dietary control, stabilization of body weight and glucose strain, convergence toward metabolic equilibrium after 2021. In other words, as the internal energy flow calmed, the geometric pattern contracted, confirming that both models reflect the same irreversible recovery path, from metabolic chaos to equilibrium. Conclusion. This 9-year normal glucose range study of simple glucose energy model demonstrates that combining VMT and TDA provides a complete view of type 2 diabetes dynamics. The VMT method explains how stress-strain energy transforms over time, and TDA visualizes how these changes form smoother and more stable shapes. Both deterministic analyses confirm that long-term diabetes control depends on 3 key factors: reducing body weight, limiting the intake of carbohydrates and sugars, and maintaining consistent daily walking exercise. These findings are fully consistent with established clinical evidence. Based on pathophysiology, recovery is not linear but follows a nonlinear, irreversible physical law, 1. Where energy balance and geometric regularity evolve together toward health stability. True healing happens when energy dissipation and geometric contraction align, when lifestyle, behavior and biological adaptation finally move in harmony. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is provided for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article, and its related materials belong to the author, Gerald C.